Welcome. In this SPSS video tutorial, we will be discussing on simple linear regression. First, we have to check whether there is any linear relationship between the variables. Second, we will be checking correlation. Thereafter, we can proceed with simple linear regression. So as the first step, we will be checking relationship between two variables using scatter plot. For that, we will be selecting graphs, then select legacy, then select scatter dot, simple scatter, and we will be selecting variables. For y, we will be selecting y. For x, we will be selecting x variable. Press OK, and you will see data are dispersed along the graph. So if it is on a line, this kind of a line, then of course we can expect strong positive relationship. However, this is a bit of positive relationship. So we will be moving on to the second method, that is correlation. So we will be moving on to analyze, then correlation, bivariate. Select the two variables, that is x and y. We will be selecting correlation Pearson. Thereafter, we will be selecting two-tailed. This means this indicates only whether there is relationship, and it does not indicate whether it is positive or negative relationship. So select two-tailed and OK, and you will be getting Pearson correlation, and that is 0.448, and this is significant at even 1% level. So if you run the analysis again using analysis, correlation, bivariate, and select one tail, and this indicates significant, and this is positive relationship. As the third step, now we know there's a positive relationship. So we will be moving on to analyze these two variables using simple linear regression. For that, select analyze, regression, linear. You will be entering the variables. Dependent, we will be selecting y. Independent, select x, and no need to select method since this is a simple linear regression analysis. Under statistics, select model fit, R square, descriptives, and estimates, and also confidence intervals. So when we are elaborating, for an example B1, you can say in a comprehensive manner along with confidence intervals. So that we will be selecting those two. Thereafter, under residuals, we will be selecting Durbin-Watson. Important thing here, for simple linear regression, we have to satisfy several assumptions related to residuals. Residuals mean should be 0. Second, no serial correlationship. Third, distribution should be normal. Fourth, homogeneous variance should be there. So in order to check those assumptions, first we will be looking at serial correlation and select Durbin-Watson. Thereafter, select case-wise diagnostics and outlier outside 3 standard deviation. Since most of the outliers are, if those are there, and if it is so, it is beyond 3 standard deviation, so that we will be selecting 3. Then continue, and under plots we can request for a graph. So we'll be selecting under Y residuals, and under X we'll be selecting predicted values. Thereafter, in order to check the residual normal distribution, we'll be selecting histogram and also normal probability plots as well. Then press continue. Then under save, you have to select unstandardized values under predicted. It will be checking homogeneity. Thereafter, under residuals, select unstandardized in order to ascertain normality. Thereafter, select standardized in order to check the outliers. These Mahalanobis and Cook's distances will be not selecting, and these are mainly for multiple linear regression. So press continue and then OK. And now we have the output. So first look at R square, and we'll be reporting adjusted R square, that is 19% of the variance of Y has been given by X. That was this adjusted R square, adjusted for items given here, adjusted for degrees of freedoms. The value is 19.3%. Next, we will be looking at Durbin-Watson test, and since that is 1.9 closer to 2, so there is no serial correlation. So if it is around 0, then positive serial correlation, around 4 negative serial correlation. Then we will be looking at ANOVA table, and that's significant, so that we can proceed with explaining Y using X. And next we will be looking at coefficients, that's B0 and B1. For an example, here Y equals to B0 plus B1X. Here the beta values are there, so we can elaborate these two are significant, meaning, and it indicates in the lower and upper bounds as well, as those are both are in positive side, indicating significance. And when we look at B value, that is for X 0.439, what does this means is, when X improve by 1000 points, Y variable will be increased by 439 points. Thereafter we have to look at residual statistics. As we said earlier, mean should be 0, and mean data are given here. And next thing what we have to look at is standardized residuals, and those are below positive or negative 3. If it is above that figure, then of course we need to identify and drop those and run the analysis again. Thereafter we have to check normality, normal distribution, and as per histogram it is there, and as per this diagram also it is along the line, so normality is there. Even this one is scattered. However, in order to check normality of the residuals by way of the case and SW test, we have already requested in our analysis standardized values, that means predicted value, standardized predicted value, standardized residual, and standardized residuals and unstandardized residual. So we have requested those three values in our simple linear regression analysis. So now we will be moving with the analysis of normality for residuals. For that, select Analyze, Descriptives, Explore, and you have to select Unstandardized Residuals, and thereafter Statistics, select Outliers, and under Plots, select Normality Plots with Tests, and histogram also selected, and continue and press OK. And now you will be noticing case and SW test results. Both are non-significant at 10% level. What this means is residuals are normally distributed at 10%. So we see that this figure is not significant at 10%, and even SW test is not significant at 10%. So with that, we can assume residuals are normally distributed. Even those are depicted here in these graphs as well. So we have already come to the end of the simple linear regression video, and when processing simple linear regression, follow basic 3 steps. First, analyze the linear relationship by way of scatter plot. Second, see the correlation. Third, go forward with the simple linear regression analysis. And with that, we will be concluding, and thanks for watching.